Good afternoon and welcome everybody out there from Vienna, Munich and Utrecht. My name is Stefan, I'm managing partner at HAKOM Time Series and I'm here together with our experts Jeroen from Axual and my colleague Ricardo. Hi.
Hello everybody.
Last time we talked about the quantum advantage for energy-driven use cases, and once more thank you so much for your contributions and the positive feedback. For today's topic, we could even set a new record with 100 plus subscribers to our webinar on LinkedIn. So this is a big motivation indeed for us. Today's topic is one that with no doubts concerns almost everybody working in the energy sector, as it's about the ever-growing data flow. Therefore, we'll talk about streaming data in the energy industry. HAKOM is in social media, so please subscribe to our YouTube channel for more content. Follow us on Twitter, LinkedIn for more articles and tech news to find out why we think that life is a time series. Time series have been our focus for many years in our work for the energy markets, as we regard them as the elementary particles of the energy industry. And with a constantly growing base of more than 100 companies in over 15 countries already using our time series platform, it's our mission to make energy data valuable. So now, first of all, let me introduce Axual. Axual, which is also the name of the technology, offers a complete streaming platform for businesses. It's a Dutch company with a size of 25 staff members that have dedicated their work to deliver a self-service for Apache Kafka. They have a special know-how in the verticals finance and energy. We came across them several months ago at a client and immediately found many parallels in our approaches. We want to make life easier for our users and make big data valuable. While for us, it's time series, Axual is generally about big data streams. Their technology is built on top of Apache Kafka, which is a distributed event streaming platform. Kafka was created in 2011 as LinkedIn's mechanism to handle the trillions of messages passing through its organization. And in the meantime, it's used by more than 30% of Fortune 500 companies. Axual currently supports clients in the energy industry, in grids, customer support, and energy trading use cases. And they achieve this by enhancing the Kafka streaming platform with valuable features such as easy configuration, deployment, security, and data governance. In doing so, they promise a journey of just a few weeks from planning to production. So I'm especially proud to welcome their CEO and co-founder, Jeroen van Disseldorp. Thanks for joining us today. Once again, Jeroen.
Thank you for having me.
Jeroen will share some general thoughts on streaming data and will then introduce some use cases. Ricardo will then comment on Jeroen's thoughts and especially mention issues in connection with streams of time series. Thanks also to you for joining, Ricardo.
My pleasure.
Before Jeroen takes over, let me start with some general considerations about why data streaming is particularly important. In our last webinars, we talked about the data processing challenge in the energy sector. We called it the energy data jungle, with many different data sources, storages, and at the bottom, as you can see, various applications. And most of those apps depend on data coming in from many different sources, and some needs to be processed in near real time. Positioning our time series technology in the middle, harmonizing and validating the data will make it much easier to handle complex use cases. But what we do not see here is the way the data is flowing. And this can in some cases be decisive. Is it still possible to manage the data flow simply by batch processing it? Or will it be absolutely necessary to stream the data near real time in order to not get any bottlenecks? The answer is to open a new path for this flow, continuously streaming the data, and this requires for specific technologies. And here I ask Jeroen to explain a little bit more about that. Jeroen, please jump in.
Thank you very much, Stefan. Yeah, before going into some use cases, let's first see what a streaming platform actually is. Many of you may have already heard of streaming or maybe already applying streaming technology on enterprise. But we think it's also important to have a bit of a concept around a streaming platform. What can you expect from a streaming platform? What is the promise that a streaming platform makes to the rest of the organization? And therefore, we came up with the concept of seeing it as a marketplace where business events are exchanged at the moment that they occur. And a business event here would be something loosely defined as something that happens to which some part of the organization may want to respond. So that could be a reading of an energy of a smart meter. It could be a sensor from a grid somewhere that emitted a measurement, but could also be something that has to do with billing or accounting or administrative processes. The idea is at least that the streaming platform is the place to be if you want to know about what is going on at this very point in time. So different applications connect to the platform from all departments of an organization. That's why you see the picture on the right-hand side with all the departments. Everybody speaks their own language in terms of if you want to do a marketing event, then you publish a marketing event, but it should be understandable for everybody in business meaningful terms. And therefore you see three types of interactions with the streaming platform. You have producers of information that detect a certain event in the real world, convert it into a message, and then produces onto the platform. You have consumers of information that subscribe to particular types of events, and they handle them as they get produced on the platform. And you have a combination of the two, and these are called the streaming applications, usually stateless applications because they consume data from the streaming platform. They process it, so they do a calculation or an aggregation, and then output their results on yet another stream. So between handling messages, they are fully stateless. These types of applications are called the streaming applications because the data really flows through them and they don't keep any state on the side. Now, this promise is being picked up by many companies in the energy sector already. And let's look at a few examples of that. So the first one would be a use case of an energy company, Eneco. If you don't know Eneco, it's an energy producer with a firmly defined green strategy. And they're really an energy provider that want to push the energy transition forward. Apart from producing energy, they also operate heat nets. And for this heat net, they also applied a streaming platform. So they collect sensor information from the heat net itself. They also collect thermostat information from people's homes and offices. And what they do is they measure whether the residual heat from factories is actually enough to warm people's homes and the connected offices. So by combining the sensor information from the heat grid and the thermostats, they can actually balance supply and demand much better than they did before. And their use case is set to save up to 30% energy. They're halfway there, I believe, as I read recently, but they expect to save even more, leading up to the 30%. And this is all just by combining data that is being transmitted by the sensors in the grid and by people's thermostats. So that's quite a strong use case of applying real-time data already. And to give you an indication, they have many more use cases on the streaming platform as well. So all kinds of equipment movements are being transmitted, all sensor data from the heat net, but also from wind and solar production, asset production schedules, parameters for local software, and they do all kinds of anomaly detection and they transmit the anomalies across the streaming platform. And by having the streaming platform, all the departments on the right-hand side, so it's both the OT domain, the operational domain, but also the IT domain on the right-hand side is able to get their hands on the data as it gets created. Another example would be, next slide, Enexis, which is a grid operator in the Netherlands. They operate like a third of the country's electricity and gas grids. And they have many different use cases that they expect around the energy transition that are in need of streaming. So they recognized that need 2 years ago, and they procured a data streaming platform. They didn't have those capabilities yet. They also chose to not build those up. So they were looking for a platform that they could get from cloud and then deliver directly to their local development teams for them to transmit their messages through the streaming platform. So what they did is they used our SaaS version, the actual cloud version, as a streaming platform that they hooked up to the smart meter measurements that they do, and they exchanged with other organizations in the energy sector. They branch off some of the data to BI systems, and they connected it with all kinds of other technologies as well. So you see a few listed here in the third bullet. Currently, they transmit, well, between, I think it's a bit higher now, but between 16 and 20 million messages per day across many different streams. and that allows them to be on top of the situation for different use cases. The third one is actually an anonymous one. The company, our customer doesn't want to be named by name, so we anonymize this one. But this is an energy trading company who collects and harmonizes large amounts of information to provide a competitive advantage for their traders. So they do short-term trading on the short-term electricity market, and by being the first one to know about certain situations in the market, they're able to profit from it by trading faster than other parties in the market. They have a set of different applications that they all hooked up to different kinds of sources. So it's market information, it's weather information, it's information about production outages, and they all combine that to provide real-time insight to their traders so that they are aware of where money can be made. We have different use cases as well. There's a couple of recent ones on the next slides. So there's another grid operator, DSO, called Stedin, which is also able to, planning to deploy a streaming platform and connect around 20,000 assets to that in the next few years. And we just won a European tender with Tenet, and we'll also be providing a streaming platform to Tenet in the next few months. So those are the typical use cases. Why are all these companies in the energy sector interested in getting a platform? I think some of the cases that I mentioned made it clear already. But there is, the speed of information is only part of the solution. There's also another aspect to what companies in the energy sector are looking for. And that's depicted by these typical personas that you meet. Because obviously the energy sector is highly regulated, and there's a lot of aspects that you have to deal with when doing data exchange between different parties within your company, but also within the sector. So for instance, you have a data owner, somebody formally responsible for customer data, for energy data, that always wants to be in control of the data. IT architects are looking for requirements that need to be met, but especially around security and stability and availability. Developers, they need to be independent and not rely on a central team to deploy the configuration on the streaming platform. So ideally, they would like to develop quickly and independently. Operators, obviously, they want a predictable and maintainable streaming platform. But then finally, legal is also looking over everybody's shoulder to ensure compliance with local laws and regulations, and also having the ability to prove it to the local regulators. So this is a set of requirements that is usually not met by a streaming platform in itself. And this is why we have created a lot of tools around the streaming platform, with the streaming platform delivering basically the speed of information. And with our tools on top, companies are able to also provide speed of innovation. And that is being done as follows. So we build on generic infrastructure, being Docker or Kubernetes. On top of that, you get your streaming platform. So that's the layer where you deal with the information exchange. So we talk about Kafka clusters. If you have multiple clusters at different locations, there's synchronization in the middle. And there is a maintainer that does technical maintenance. It operates the cluster. This would be a typical Linux maintainer or a Kubernetes maintainer that watches out for performance and availability. But this person is completely not aware of all the data that is being exchanged and the applications that interact with the streaming platform, because that is left totally up to the teams who connect to the data governance layer. So there is a data governance layer on top where teams can log into a self-service interface and they can basically define their piece of the streaming platform. So if you have a role of data owner, you can create topics and you can set schema for them. If you have a role of application owner, you can register your application, and then through a request and reply process between the two, you can get access as an application to a particular piece of data. Everything in that system is being audited, giving you full explainability to local regulators. Now, behind that self-service interface is also a REST API. Many companies that start out with using the UI, but sooner or later want to move to a more automated way of deploying configuration on the streaming platform, and therefore you also have the possibility to use the REST interface with a CI/CD process or through GitOps. All your applications that communicate with Kafka are compatible still because they interface with the streaming layer itself. So the data governance layer is purely meant as a configuration ease in full compliance with all security and governance aspects. And I think that's a short explanation of the streaming platform and why it is interesting for the energy sector. So I give the word back to Stefan.
Thanks so much, Jeroen. And thanks also for the questions we've got so far. I think it's obvious that the streaming data is absolutely essential in future, as many of the new data flows will require for such technologies. So I think that's the right time now for Ricardo to jump in. Please give us some ideas on how we can actually start to set up this continuous data flow in parallel to the batch processing. Ricardo.
Thank you, Stefan. I think I'll begin by taking a step back and show an overview of how our HAKOM TSM framework architecture is depicted in the diagram that you see here in the screen, showing how it interacts with upstream sensors or downstream applications, clients and processes, which you see here on the left side, as well as with the various persistence options on the right side. And our time series service is placed in the middle with various features that are highlighted there. And if you're interested in those features, be sure to check out our webinar, The Backbone of the Energy Industry, which we streamed a couple of weeks ago. But I'll make a note here first that our domain layer, which has all this processing logic, is actually composed of a number of stacked components. That's to symbolize that it runs on scalable resources. This could be a virtual machine with multiple cores, or more likely a number of containers in a Docker or a Kubernetes environment. And the important thing here is that the value of the time series service lies precisely in that it abstracts all the data model as well as the storage layers to this outside world. Like Stefan mentioned in the beginning, it's a fabric connecting the elements in a way that a client application or a device sending data doesn't need to know what will happen after the data is transmitted. So the service takes care of that. And if we go to the next slide, we'll put this in a slightly different form to better illustrate how the data flows across the service. The elements that we had on the left side before are now spread on the two extremes of the slide. So on the left, we have those elements that are generating data. And on the right, those applications, platforms, dashboards, which are the consumers of the data. And a typical solution architecture will involve tools for the ingestion of the data. So dealing with monitoring what is taking place, a schedule of when to pull data from which source, and perhaps according to different parameters like attributes or the metadata in general, deciding how to proceed. This ingestion tool will then feed the data to our API, which deals with transformations. This can be unit conversions, adjustments on the resolution, or all the other aspects related to data quality, such as cleansing the data, creating replacement values when data points are missing. Maybe you also need to correct for outliers. And from that point, you feed onto the actual API for storing the time series values. This part of the API deals with identifying what time series is stored where. Maybe there are different databases being used. Maybe it's a hybrid environment where some of the storage is on premise, but other resources are in the cloud. This means actually this data storage icon that we're seeing here could be multiple icons, but that doesn't matter. That's transparent to the outside world. And finally, this API exposes endpoints for the outside world to get hold of the data. Those are the applications on the right side, which submit queries asking for time series data for a certain time period, and then get the data back in whatever format, resolution, unit, or maybe aggregated form as they may desire. But as we've seen, Jeroen shown, there's a whole different paradigm for dealing with data that streaming brings with it. And the good news is that we can keep our existing components, but simply change the way they interact with the data flow. So now let's say our data sources are all streaming data onto the actual platform, and we can skip the batch step and instead allow the transformations or the data quality steps to latch onto the stream. So we have a subscription from our transformations customer, which will deal with those conversions or cleaning steps that I mentioned before. And they again push their output back onto a new stream topic. And this topic can again be subscribed by a dedicated time series consumer. This is what we're calling here the time series subscriber, which works as the interface to pipe data from the stream to the API for persistence or for other tasks such as analytics that may be computed combining live and historical data. And this way, it's again available to other applications in the usual way for them to query and fetch data like they did before. And I think this allows us to reach a conclusion, if we go forward, that we can put the two paths together and realize that the very same components can fulfill their roles over two different paths. So two different ways of exchanging data. We would call a hot path, in red, the data streaming, as well as in blue, the code path for traditional batch processing. And this gives you a lot of flexibility in deploying the services in a range of scenarios, so both streaming and classical, if we call it this way, without having to reinvent the wheel or develop the same functionality twice. And this has the benefit that it ensures all your transformations are consistent, that you're always doing the same formulas, the same unit conversions in the same manner, and also that you have a unified view of the data for the outside world, which is exactly what you want to achieve with a universal time series fabric. So that wraps up from my side, and I give back to you, Stefan.
Thank you very much, Ricardo. So there are certainly ways of managing this data flood that's coming upon us, and it seems to be a question of the overall solution design, as well as the choice of services that go along with each other and ideally are reusable. So before we start with the Q&A, as always, there's our call to action. If this sounds interesting to you and you would like to know more about it, you can schedule individual one-on-one online meetings with us to discuss things related to time series and streaming. On a short message, we will send you a link for you to select an appointment. Or if you already have a clear use case in mind, join us for a half-day workshop at a very reasonable price. And you could share it with us, your challenging time series streaming use cases. We will study it and have a workshop together with you discussing how a streaming platform in connection with our time series service might be useful for your particular challenges. If you're interested, please send a short message to tsmlab@hakom.at or use the chat function. We will contact you later on for the details. So I've seen a lot of questions coming in. I will start with one, I think that goes to Jeroen. Maybe it's obvious already, but still I pose a question. How does this platform differ from an enterprise service bus approach? Jeroen.
The enterprise service bus approach is really oriented towards integrating processes where you see chaining of different steps being done on the ESB itself, and it's really message oriented, whereas the streaming platform is really event oriented. So it's publish subscribe. So that means that the producers do not know which consumers will receive the data. It's like almost like an internal broadcast in your organization of something that happens. And it's up to the other applications that are interested in that message to subscribe to the relevant streams and to ingest that data as it gets produced. So that is the way to orchestrate processes, usually in an ESB fashion, happens on the ESB itself. And around events, it usually happens by applications just connecting and interacting with the streaming platform. So there the orchestration is more or less done by the total set of applications that happens to be online. Yeah, so that's, I think, the major difference.
I think that wraps it up. Thank you very much. Another one, this one could maybe go to Ricardo. Are you using any specific data storage, referring to the TS data storage? If not, what is supported and recommended?
Mm-hmm. That's a great question. If you could go back, I think that's slide 15 or 16, or maybe even to slide 15, we'll have an overview of how the architecture interacts with the different databases.
There we are.
There you go. And the answer is we don't strictly recommend one type of persistence. It really depends on the use case, whether you can use a traditional relational SQL database. Some cases, very particular ones, require in-memory storage. now we're also working with horizontally scalable technologies and even some new SQL that combine horizontal scalability with relational database querying and transaction security. So it really depends on the use case. It depends what is the complexity of the queries that you need to do on the data afterwards. And of course, also the volume of data. In some cases, you will have more volume, but in batches, in some cases, you will have, like we're describing here, a streaming flow of data. And there is no one size fits all, but that's why we keep the entire logic in this middle component so that we actually have very little logic at the database level. And this allows us to connect to whatever persistence form may be more suitable for the storage.
Thank you, Ricardo. This one goes to Jeroen. What are the key differentiators of Axual compared to other managed Kafka offerings like Confluent, Instacluster, Avon, and some others? Jeroen?
Yeah, I think what we have done is we've packaged Kafka into a complete solution that does not only take care of the information exchange, but also, like I said, the speed of innovation. So there's a self-service, a governance mechanism, a security mechanism. Sometimes when you buy these, what we call like raw Kafka deployments, you have to complete the architecture yourself. So there will be a design and build phase for you to install those systems or to configure them as such to align them to the way you're used to work in your enterprise. And with our platform, there's a lot of this already pre-configured. So we found out in practice what is required by large organizations, how decisions are made, how responsibilities are shared. And the model that we have is well suited for especially for larger organizations with a complex way of making decisions and complex way of assigning ownership to certain data items or to certain responsibilities. So that's like all configured in the system already, and it's like, you know, you install it from the cloud version, you get to go right away. But if you want to install it on premise, it's a matter of weeks rather than months or years to set up such a platform. And that makes it very powerful because and it also makes it less risky because you don't have to make all these complex decisions and design decisions yourself. It's already that's already done for you, and it's been proven in practice.
Thanks, Jeroen. Next one, I can let you choose. Does the streaming platform do any computing on the time series data, or is it more treated as a modern cloud-friendly service bus?
I think I can begin and then pass on to Jeroen. As we showed, there is a transformation component that is not strictly the streaming platform, but it's a subscriber to that, and it will stream again, transform time series. So it's not like the platform is acting on the data, but a component that is connected to the platform and both consumes from the stream and generates its own stream will be handling transformations or any additional manipulations on the data points.
Yeah, and adding to that, I think that will always be the case. The streaming platform in itself is really a transport mechanism. So that means that any transformation logic that you apply to the data will always be, from our point of view, it will be our customer's logic. So if you transmit time series across the streaming platform and you want to do data quality, cleansing, transformation, aggregation, it will always be, well, either your logic or HAKOM's logic that applies to time series. The streaming platform in itself will not do these transformations, although we do have accelerator functions that allow you to do those transformations more easily. So for instance, we recently launched a mechanism called KSML, the Kafka Streams Markup Language, which is a way to not have to write complex Java applications or other types of programming logic yourself, but you can specify in YAML what steps data needs to go through. And then we generate that particular function for you under the hood. And you can execute that by yourself in your own standalone Docker container. Or in the future, you can also execute that server side on our end. But we would also always treat that functionality as being customer logic. It's basically your logic that you can then offload to our server-side platform, but it won't be part of the core streaming platform itself. It will be an application that you run on our end to not have to do that yourself.
Great, Jeroen. Thanks a lot. There are still some open questions, but with a look to the time, I'm awfully sorry that we need to finish the main part of our webinar now. As usual now, I would like to mention our next webinar that we planned for November. Today we talked about the data flow, and next time it will tackle all questions on how to store the data. Which technologies shall we use for which use cases? We hope that you'll join again. So please stay tuned to us. Have a good start into the autumn, and do not forget, life is a time series.